Hello again, and welcome to the Inside Products podcast. I have with me today two very special guests from a recent acquisition that we made of a company called Galileo, Yash and Atin, and we have Vikram, who's the third musketeer, who is not here today because he has had a new addition to his family, so he's enjoying well-deserved time with his family. So we'll make sure that we have him on the next pod. But welcome to both of you.
Thank you.
And
Thank you.
before I get started, you folks have had an amazing background. You were at Google, you worked at DeepMind. Talk to us a little bit about that. What did you do over there, and what learnings did you have before we go into how did you think about founding Galileo and what happened from there?
Yeah, so I've before we started Galileo, I spent about a decade working at Google building conversational AI systems. We started with very rudimentary speech-to-text systems, and there was a time when we were able to convince Larry, Sergey, and the business that conversational AI is going to be extremely, extremely important. That's going to be the main way by which the
People
world
interface
consumes
with tech. Yeah.
Yeah, and so we've gone over a whole host of models over the last decade, whether it's like right from Gaussian mixture models to RNNs to DNNs to transformers and then to large transformers. Right? And I think the big unlock that LLMs, which is the large transformer architectures, have had is we didn't have to really hard code the natural language understanding parts into like a hard coded workflow that initially these assistants were built on. And on top of that, these models became multimodal. And so, when we were part of this, early team that was building out these models and scaling them.
Yep.
We worked with, Demis and team as well. And on top of that, our team powered about 20 plus products at Google, whether it's the Google Assistant, but Google Cloud and Google Meets and the cars and the home devices and the phones. So
You had the same voice engine that you had actually...
the same conversational AI engine. So it's
Right.
it's the voice and natural language understanding along with actions that you can do in different modalities. So I think that's...
Were you in charge also? Did you also think deeply about like tone and...
Yes.
tonality, and all
Tone,
of that?
punctuations, and then even quality of the generated voice. Like how can we
How can you
make it sound more
human-like?
natural?
Yeah.
Exactly. And so that was adopted by contact center businesses and like the meeting. In COVID we saw a huge spike in these Google Meets and WebEx and all of these products, and then conversational AI transcripts. And now we take that all for granted now, but like that was a tough time for us to scale this technology to long form speech and long form conversations. So that's where I come from, and towards the end of my stint
And
at
you
Google,
currently run research and core engineering
yes.
in this team, and then Atin, you run the product and the engineering side.
That's correct, yeah.
And so Atin, what was your background?
So I started my career in the earliest days of Siri. Worked on some of the first versions.
With Tom Gruber.
Tom Gruber, yes. And this is still in the ImageNet, AlexNet days where deep learning is still kind of in the labs. But really learned how to build end-to-end productionized language systems before deep learning models were a thing. Spent a few years there and then really joined a very interesting team at Uber back when Uber was on a tear. They were growing and they had barely any AI footprint. It was a team of 6 or 7 people. It's known as Michelangelo. And we literally built out their entire AI system.
Was this before Monic or during Monic's time?
This was before and during.
Okay.
Yes. But we really were a few of the folks who built out end-to-end AI infra and the foundations and blueprints, which have been adopted pretty much across the globe. We were one of the first to build feature stores, which are data systems for machine learning models, as well as monitoring systems, where I really saw the battle scars of how do you make AI models do the right thing and how do you measure them. And then met Yash and Vikram, who were solving the same problems at Google. And we sought out together and we said, how do you solve the trust problem in AI?
For unstructured data and language models in particular. Like that
So
was
So unstructured was one of our key pillars. And we said that we want to build for the next 10 years of AI, not the past 10 years.
Right.
Because we had seen deep learning models get cheaper and cheaper to productionize. So we saw that coming. We didn't, of course, foresee exactly how it would manifest, but we kind of feel like we hit the nail on the head on the unstructured vision. And not only did it, was it exciting for us because it was future facing, but we feel like we spent the first couple of years before a ChatGPT happened really building the foundations of understanding AI models.
Yash and Atin, what I'm going to do is I'm going to take a step back and say, if I were to think about how observability for AI is broken down in my mind, there are three distinct components to it. Number one is the observability for the infrastructure itself. So how are you going out and measuring resilience of the infrastructure?
Yeah.
GPU utilization, uptime, all of those pieces. Networks. The second area then is agent behavior observability, where you can actually see how the agent is behaving, seeing if they're behaving in a way that you don't want it to behave, and when that is happening, can you dynamically at runtime intercept to kind of alter that behavior. And then the third area is around tokenomics. Is the consumption pattern of tokens for these agents within the boundary conditions that you want to actually have, or is it actually going out completely in a different stratosphere, which could then create a very, very different economic impact for you? Yeah. Am I missing anything in that? And then what are the things, how are you folks thinking about how Splunk fits into that entire picture?
I mean, I think Jeetu, these three things, literally cover the entire agentic stack. While infrastructure seems like, we sometimes ignore infrastructure and think that it's commoditized, but as agents are scaling, we are seeing customers hit infrastructure bottlenecks very quickly.
Right.
As we all know, just the networking impact of agents is just 450 times that
That's
of
right.
a human. And so our customers are actually asking us for an end-to-end observability across not just the agent behavior, which we talked about in quite depth already with evals and enforcement, but how are the infrastructure components dealing with agents? What network accesses do these agents have? What are the security layers that we can put on? Because without observability, you can't have security.
Right.
And so if we want to run agents, whether it's in a desk side computer or it's in a server rack or it's in the cloud, without end-to-end observability, we can't enforce the right guardrails around the agentic processes. The next thing is the final piece is tokenomics, where tokenomics is actually bubbling up quite a bit now as something that's of importance. But we've always tied the end outcome, the ROI of agents, to the spend that we're making. It's when we talk to customers in the past, in the first couple of years of post ChatGPT, we've had so many dinner table conversations with CIOs and saying, hey, I spent $15 million on LLMs. What's the ROI? Like, are we shipping more product? Are we actually moving the needle on our revenue? And the answer has been no in the past. But now I'm starting to see that change, where there is measurable revenue, there is measurable impact, there's measurable productivity. But the thing that's missing is the infrastructure to measure that itself. How can we quantify and tie the agent's behavior and the token spent to the business impact
to the value
and the
that
ROI?
you're going to receive.
Because what leaders want to actually do is, we don't want to spend less on AI. We want to spend more on the right pieces that are giving the right ROI. There are 1,000 things going on with AI. There's a lot of tinkering going on.
So give me a concrete example that a customer can say, if I have these class of problems, I should be thinking about observability for AI with Splunk.
So there are three classes of problems. When we think about who needs observability for AI, most enterprises today are having some form of agentic behavior in their workflows. These are tools and productivity tools and coding agents for their developers.
Right.
That's the biggest spend today, and that's the biggest amount of agentic activity. That being said, the first party and third party agents, those are the other two categories, where first party agents are the ones that enterprises build themselves, and that could be around their internal workflows, but also consumer facing products. And third-party agents are the entire agent sprawl we are seeing in every SaaS provider,
Yeah.
having their own agents.
And
Now,
you want to make sure that you provide observability for the entirety of the estate of all agents.
it has to be.
Yeah.
We cannot just have like blind spots around. Oh, I measure my first-party agents, but what about the rest? Like
Yeah.
But the point I was trying to make is the agentic behavior in products and services is only growing, and today is just the early days. As more and more workflows in our tools, in our products become agentic, the spend on and the observability needs for agentic on first party, third party will increase. But today, as we stand, we cannot ignore the coding agents and the tools, that vertical as well.
So I'll come to you, Atin, on the product side of the house, because there's so many products that actually use these terms that sometimes it's hard for a customer to say, I can't tell the difference. So here's my question to you. If I'm a customer at a bank or an insurance company or a pharmaceutical company, pick an industry or a vertical, what is a concrete example where what you do and what we do with Splunk Observability for AI can meaningfully change the game on the kind of value they harness from AI?
Absolutely. I'll give you a concrete example, say, of a healthcare company, right? They're building workflows to solve to make critical decisions on, say, prior authorizations of expensive drugs, right? They're using GenAI to solve it, and
Right.
they're building agents to automate this whole gnarly process. And it's ripe for disruption because these workflows are just filled with unstructured data, PDFs, documents, and LLMs are, for the first time, we have technology that can make sense of it and take actions for it. So we have the ingredients. Once you build an agentic workflow, a whole host of things can go wrong at many layers, including the three layers that you mentioned. I'll talk about the first layer, which is tokenomics, and second layer, which is the
Agent behavior.
The behavior.
Yeah.
Starting with the behavior, one wrong mistake that the agent makes because of a loose prompt or a wrong instruction can lead to a bad action, which in this case would be the denial of a drug for a patient in need. So the results can be catastrophic because of wrong behavior. Then there's the cost aspect to this, where tokenomics comes in. And I'll tell you how layer 2 and layer 3 are related, right? There's the absolute measurement of tokens that
Right.
will be needed to take this action, including parsing all the PDFs, the docs, the insurance docs. All this requires tokens, and we can't escape that.
Right.
But the question is, how do you do it efficiently? Because these models are probabilistic, they can go wrong, and they can spin into loops. So it can be very expensive to get this action done. So the problem to solve is, one, measure the total number of tokens it took to take the action, and two, whether the action was taken or not, which is also a key part of tokenomics. But the insight and the signal for whether the action was done right or wrong comes from the layer below. So that's a...
Okay, so I measure whether or not the key actions taken with the use of tokens. What do I do if I find out that, like, what's a good scenario and a bad scenario in that particular instance? And what does our technology help with on that front?
A good scenario is that there's action completion happening, which is the agents are doing
Yep.
what the instructed action is, which is to approve or deny the drug, and do it with high saliency or high accuracy. The bad scenario is, of course, doing the wrong action. But the bad scenario could also be you did
Very
the right
consumptive
action,
on tokens while you're
extremely
taking it off.
consumptive, extremely slow. Because, whether it's a healthcare workflow or an e-commerce application that can, deliver goods to you and issue refunds, the architecture of agents behind the scenes is the same, and they have the same proclivity to,
Yeah.
the errors that they can make.
So why did you folks feel like being part of Splunk would actually be additive to your mission? Like, what was it that Splunk brings to the table that you felt like you didn't have?
I think, to my point earlier, the thing that we're super excited about is that Cisco is building the critical infrastructure for the AI era. Splunk as a business overall is looking at solving the digital resiliency problem, and agentic or AI resiliency is the next chapter in this entire business. we also heard from our largest customers, some of the largest Fortune 100 customers, that they have an entire digital resiliency stack, whether for application monitoring, for enterprise security, and then as more and more services start becoming agentic, they asked us, is like, how is your platform going to tackle all of it? Because we want the entire digital resiliency to be in one end-to-end flow, in one end-to-end solution. And so from a product and technology perspective, what we've built is extremely additive as well as strategic from Splunk's customers as well as Galileo's customers.
This is truly a full stack observability solution, from infrastructure observability, application observability,
tokenomics,
and then going into agent behavior, tokenomics, and pulling it all together in a way that's one cohesive interface in Cisco Cloud Control.
Absolutely, and there are apart from Splunk's capabilities, also Cisco has the AI defense aspects, the defense claw and AI defense pieces that actually fit in very well with the story, as well as the Thousand Eyes and security solutions. With all of these capabilities, Cisco can truly provide the solution for critical infrastructure for AI agents. Like it's not. I'm not saying that lightly, because this one bespoke point in time solution is not going to solve and the overall problem to build, and all of this allows us to build the fabric for digital resiliency, agent resiliency across agentic software.
Whether you take the example that took Fable down, right, or the healthcare example I just gave, these are anecdotal examples of singular workflows that, of course, have the same failure patterns. But really, when you imagine an agentic fleet running in production, that happens across multiple devices, multiple data centers, multiple availability zones in the cloud. And to detect a security issue in an agentic flow, the data can come from anywhere. So providing, number one, the unified data fabric, to be able to, a unified interface across all your data. You need that to solve the security problem. You need observability on all this data to solve the security problem. It all blends into one another. So having this full stack really is saying that I have the key ingredients to solve agent reliability. And Cisco, from what I know, is the only company in the world that has that.
And to your point, like, Cloud Control stitches it all together, and we're super excited about where we're going in the direction. Every product in Cisco can be operated.
You folks integrated into Cloud Control in like 2 or 3 days or something like that, right?
Yes, and
we
literally we joined Cisco, and in a week at Cisco Live we demoed Cloud Control with agent observability and tokenomics, and so that's been an incredible journey as well, because it's so easy to build Cloud Control apps now that every product in Cisco can be operated through one interface.
So let me try to summarize and see if we can actually, and correct me if I'm wrong on any of this stuff. In order for us to have agents do work on our behalf, what do agents need? They need to make sure that they're treated as digital coworkers and have tools access. Mm-hmm. In order to have a pattern where we can delegate to the agents in a trusted way rather than an untrusted way, what you have to do is protect the agent from the world, so that if there's prompt injection attacks, there's data poisoning, all of that stuff's happening, we can figure out a way to intercept it.
Yes.
With things like AI defense. Mm-hmm. And number two, we can also make sure that we protect the world from agents that are misbehaving.
Yes.
And all of that has to be done with detection that happens at machine speed and scale.
Absolutely.
So what you folks have built is the full stack and the observability apparatus to ensure that all of this gets stitched together. But the key components that Galileo brings are agent behavior observability, which includes evals, mm-hmm. And then tokenomics, so that you can continue to keep refining how the agents are behaving in the consumption pattern of tokens, mm-hmm. and marry that with the infrastructure observability and the application observability that we have with Ollie Cloud, and Apti. And the reason this is really pertinent to be part of Splunk is because Splunk has time series machine data, and observability is fundamentally a time series problem. And so you want to make sure that you can actually go out and utilize that data in a way that's effective.
Even security, right? Security is now a series of events,
right?
Like the adversarial attacks I mentioned. It's all time series.
Right. Yes. And if a customer does this, what have we seen as the primary ROI that the customer gets? Like what does a customer go to bed feeling peace of mind with?
I'll just give out an actual data point. Like, one of our largest enterprise customers went from 1 agent in production to 75 agents in production in a matter of 6 to 7 months. If you have the right agent resiliency stack, then the enterprise can feel confident. All the teams with building different agents and even in onboarding agents from different solutions feel confident that they have the right playbook in place.
Right.
And that's extremely important. If we can not only deliver the right products, but the right solution is the most important thing. When we go to customers, we can say, now you have the end-to-end playbook of what every team needs to do. What is your governance and compliance strategy? And our products support all of that. That becomes magic. Like that becomes magic to our customers' ears because we're coming with this end-to-end solution that will help them accelerate.
And by the way, you folks have built your small language models, SLMs, so that we can actually lower the cost of inference as well for the observability stack that we're using. It's like down by, like we can reduce it by 95%.
That's huge. To the point that like the price that our customers pay, they actually the savings that they get from the SLMs actually make up for the price as well, and actually end up saving more.
So your inference cost is de minimis in this thing.
Exactly.
That's correct.
Okay. So given all of this, are there questions I should have asked you folks that I didn't that you want to convey to our customers?
Yeah, I think so. One of the things, Jeetu, that we're hearing all the time these days is how are we solving the tokenomics problem? Our customers have been seeing a huge spend, unexpected spend on tokens, and then they don't have the ability to measure the right ROI from their efforts.
And they don't have the ability to fund all of that either because it's hundreds of millions of dollars and people don't just have that lying around.
And we are always competing on what to fund, what to invest in.
Yep.
And so I think there are a few things that we're looking at deeply from building the right product and then also helping customers with insights. I think the key problems that we're trying to solve with tokenomics is firstly, how do we give customers the deep observability into where is the spend happening?
By which agents?
For
what activities and what tasks?
What activities, what projects, what tasks, which personnel, what are the budgets that are going off, all of the measurement part. But that's not enough. What customers have been asking us is like, how can you help us determine what's the ROI from these agents? And how do we map the spend to the ROI? And then second is, can we actually do some powerful forecasting on these spends? And Splunk with its time series data, the Cisco data fabric, getting all of the time series information, we have a time series foundation model that was built from scratch on time series data. We're leveraging these capabilities to better give customers better forecasting on their token spend. That is music to people's ears.
I think there's going to be a third area, which I'm not sure if we have fully cracked the code on, but we're going to need to, which is the dynamic interception.
Yes.
When agents start to go rogue, so that we can actually stop
that. Actually, there is a rudimentary solution today,
but it's a very blunt instrument
It's a very blunt instrument. Yeah. Like we any single prompt cannot be more than these tokens. If an agent session goes beyond these many tokens,
but over time, if you were to think about from a product hygiene standpoint, like how would you want to build this? You would want to make sure that you almost in runtime start to instruct the agent to pull back and not have that level of consumptive pattern being exhibited for the job that they're doing.
Absolutely. I mean, runtime is really the only way to curb cost, is to detect rogue agent behavior or anomalous behavior at runtime and prevent.
But not just intercept, but also influence and redirect the agent.
Redirect, exactly. That's the actionability bit.
Yeah, exactly.
So that's a key part of tokenomics, which is detecting the issue and taking the action and curbing the wrong action,
Right.
which at scale would lead to millions of dollars of wastage.
Right.
Well, and speaking of blunt instruments, there's a fourth aspect to tokenomics. Is today, speaking of blunt instruments, most users are just using the most powerful model for every single thing that they're doing. And this is another ask that keeps coming up, is like
Just have intelligent routing.
using our eval capabilities. Can we measure that you could do the same job with a 10x cheaper model and give that proactive insight
Post facto.
but
Okay.
still proactive,
So that you can then go back and actually reapply it.
because most teams are not investing the time to measure can there be a cheaper model that can do an equivalent amount of job.
Sure.
So
So that actually is a very interesting point, which is like over time, be able to say that this is how much this task cost you, but this was the distribution of the task between a frontier model and an SLM. But if you had done it with this level of routing intelligence, you would have actually seen a fraction of the cost. And here's what the cost would have been. And so that's what we're going to incorporate the next time we do something.
and while not sacrificing accuracy, because that is the
Absolutely,
most
absolutely.
Gentlemen,
thank you for being at Cisco. Thank you for actually doing all the amazing stuff that you're doing. It's a pleasure, and I'm sure we'll have many, many more of these conversations.
thank you for
Thank
bringing
you.
us here, and it's an exciting time.
It
Let's
is
go.
an exciting time. So let's take a step back now and talk about what you did and what you saw as an opportunity with Galileo. And by the way, the Galileo brand and the name goes away, and it's going to become Observability for
Splunk.
AI within the Splunk team.
Yes.
But the core essence of what you actually started became the kind of the thing that got me really excited. Right? I remember when we first met, it was at RSA, and I was supposed to meet you guys for 20 minutes, and like
Right.
90 minutes later, I felt like we were still running out of time.
Right.
And so it's been great to have you on the team now. Walk us through the problem that you were looking to solve, and walk us through why it's such a hard problem to solve.
Absolutely. So when we started Galileo, our core mission was to understand deep learning models and really quantify the uncertainty when these models spew tokens. In fact, back in the day, we used to call them seek-to-seek token classifiers. That's where the word token comes from.
Sequence to sequence.
They're sequence-to-sequence models, which means they're in sequence, saying one word or one token at a time.
Got it.
But there's ways to measure what's happening behind the scenes that can sort of measure the confidence with which these models speak. So we started there. This was way before ChatGPT, way before LLMs were a thing. But we built the foundations of understanding language models in our earliest days. Then ChatGPT happened, and we decided to go into the observability space because we saw people will start building real software on top of this technology. And we used our compounded research that we had done in understanding language models to build a truly world-class system that can not only identify nuanced issues with any system you build on top of LLMs, but they can do it at scale and at very low speed and low cost. So that brings us to today, where we have agent observability, and people are shipping agents at scale. And really, we are one of the only vendors that can truly provide full samples observability for the new class of software, which is all agentic.
So let's unpack that for a second. When you say we're the only ones who can provide full samples observability, walk me through what that entails.
Yeah, go ahead.
It's a two-part problem, and I'd love for Yash to speak on the modeling side. But it's partly a modeling problem, which means there's AI research that needs to be done to detect nuanced agent issues.
Right.
And then partly it's an infrastructure problem. Then how do you do this at scale? So we've had the privilege of having solved both these problems, and we have engineering teams that have worked on this problem for years. And that has brought us to today, where when I say full samples observability, what I mean is you need to evaluate every single event, every trace of an agent, because the mistake can be catastrophic and it can happen at any point in time. So how do you build the tech that does that and does it at agent scale? Because the traffic is no longer spiky like with traditional software, right?
It's much more sustained and durable.
Much more sustained and durable. And we imagine a world not too far into the future where trillions of agents are running and doing complex tasks. So to have an observability system that can detect nuanced issues at scale, that is the problem that we
What's an
set out to
example
solve.
of a nuanced issue to detect at scale?
I'll give you one, a very recent example: the prompt injection attack that took Fable down. That's very prominent in the news. What it was, in essence, was a series of harmless prompts to the model, which made the model forget its core character or what it was designed to do. And
During post-training?
no, during inference. At the time of inference, say, I'll give you a simple example. Say you took Fable or Mythos and prompted it to act like play a certain persona. The attack was to make it forget that persona and then spit out harmful code. And it did that despite all the guardrails, despite all the systemic level safety guards that were put on Fable.
So just the prompts that it was feeding it actually instructed the model to forget the persona.
It forgot the persona, and it set the context which seemed harmless.
But it was in fact harmful when you compounded together.
You compound it together, it became so harmful that it spat out what it was not supposed to do, which is it gave harmful code back to the user.
Yeah.
And that's the attack.
This is just one example of like how with agentic architectures and models becoming more complex and capable, we will continue to see new non-deterministic behavior and new attack vectors, which is why we absolutely need 100% observability on agentic traffic. We understood this very early when we were trying to measure how the quality of these models and how that would actually be applied in production. It was very clear to us that firstly, we need to provide a good way to measure the right behavior from these models. Then how do we observe the end-to-end stack? And it didn't end there. We couldn't just give our customers an alert and say, okay, now we show you what's going wrong, but that's almost always too late. So enforcement was always the end game. We've kind of built a quote within Galileo and now Splunk Agent Observability is that today's evals are tomorrow's guardrails, right? And that's a very useful and intuitive way to understand this. That's the main reason why we've built our SLMs to actually help our customers not only measure the right things accurately, but deploy this at scale so that we can measure every single occurrence of an agent and every single span in the agentic trace, evaluate it, and then give our users 100% observability with the right metrics. Not only that, we can pick, let's say you have about a dozen different, eval metrics that you're measuring. Maybe two or three of those are so critical that you can't afford to make those mistakes in production. With the same SLMs and our inference engine on top of that, we can run these guardrails in under 300 milliseconds at scale. That allows our customers to build real-time applications with the right enforcements in place. I think a very real example is, one of our large banking customers, right? For them, their agents just cannot give financial advice to their customers. If they give financial advice to their customers, they can lose their banking license. And so their AI has to be protected so that in any circumstance, there is no financial advice going out to the customer. They have built a custom evaluation metric on top of our SLMs and deployed this at scale so that, and this is the common pattern we're seeing across financial services, not just one bank.
And so this notion of are the evals good enough to be able to tell us whether or not the model's performing the way we need to?
Yeah.
Or the agent's performing the way we need to is super important, because sometimes what ends up happening is the models learn how to trick the eval and actually behave a certain way with an eval, but in real life conditions, it actually behaves differently.
Yes.
So walk us through what we have done to make sure that gets mitigated as a risk.
Correct. So, just like any other system, we have to think about how we can instill human expert knowledge into these evals. When we start evaluating these models, just don't pick up like random metrics off the shelf and start measuring them. They have to be tailor-made. We often, there's a myth that evals are like are like machine learning evals where you evaluate a model. Those are very different. Evals for an agent are like writing unit tests and integration tests for your application. They have to be very much tailor-made.
Yeah.
So
in fact, they are the new unit tests.
Yeah. And so, any new capability you launch for the agent needs the tests, right? Now, once, what we've realized is because these agents are autonomous and they can take any path in production to achieve their goal, a developer cannot potentially just test every single path. It's autonomous. It's going to make its own decisions.
Right.
So there are non-deterministic paths, anomalies that we have to proactively
Measure.
detect in order to surface that to the team. If we don't have that component, then just the known evals are just going to find the known unknowns.
Right.
There are unknown unknowns that happen in production that we as an ecosystem have to be ready to deal with software that has unknown unknowns.
Right.
And then how do we actually enforce and mitigate so that they never happen again?
But for the known unknowns, we need to make sure that the evals can actually go out and do that. So the way that I simplistically think about the stack, and it makes a lot of sense to me, is when I think about observability for AI, there are 3 dimensions that come to mind. Number 1 is I have to make sure that the infrastructure itself is resilient for this kind of surge of demands that are going to be there from an agent, right? And you have to make sure that doesn't slow down or affect performance of the agent, or ideally outcome of the agent because of some kind of slowdown.
Yes.
Yeah.
That would include things like GPU utilization. That would include things like latency, all of those pieces that you would typically
Token
do.
Spend and
hold on, token spend. So that's the first thing.
Yeah.
The second area that I think about is making sure that we think about agent behavior and how can we at runtime detect the behavior of agents and try to figure out a way that you can intercept that behavior if you start to feel anomalous things that you don't want to have happen.
Yeah.
And number 3 is tokenomics.
Yes.
Is the agent going off in some kind of rogue manner and starting to use tokens in a way that you don't want to use them?
Yeah.
Those are the kind of things that we have to kind of think through.